Hello everyone and welcome back to Diksha Karnataka YouTube channel. And if you are currently studying in PU board, then your midterm exam is very near, and as we are discussing all the important questions from the chapters of your midterm syllabus, today we are going to discuss the last chapter of your second PU, that is last chapter for your midterm second PU, not the last chapter. Obviously there are more chapters to be done. Ray optics and optical instrument, that is the last chapter of your midterm syllabus. So we will complete that chapter today, and tomorrow there will be a surprise, that is for all the weaker students, those who are not able to complete the portion and they just want to pass. There will be a passing package video coming tomorrow. Today we are doing the full chapter of ray optics and optical instrument. Now remember that the passing package that I am going to do tomorrow, that will be only for the weaker section. You cannot expect to score 70 marks by watching that video, but yes, if you are weak and if you just want to score the passing marks, there is a highly likely chances, 99% chance, that you will get the questions common or similar questions will come in your midterm exam. So now, ray optics and optical instrument we are going to discuss today, and let's see the chapter wise weightage of the chapter. Okay, first of all, there will be one MCQ or fill in the blanks. It is not, both of them are not going to come. Either it will be an MCQ or it will be an fill in the blanks question, but these marks distribution are for your final board exam marks distribution. Midterm there may be questions coming as MCQ as well as fill in the blanks. That's why we will do both. We will revise both in detail. Then there will be one short answer type question, 2-mark question, and possibly there will be a 3-mark numerical problem from this chapter for 3 marks, that we will also see. And there will be a long answer type question, and a long answer type question for 80% of the chance that this question will be a numerical question. Okay, because as I said, there are 3 different blueprints presented by KEA, and all the blueprints has different marks distribution, so it was difficult for us to guess which one will be important for numerical questions. But according to the previous year trend, and because 2 blueprints share the numerical question for this chapter, so I am guessing that numerical question will be coming from this chapter. And there is a small possibility for your midterm that there will be a 5-mark written questions as well from this chapter. So we will see everything, maybe not everything, but all the pieces we will touch at least. So let's start with MCQ portion. What are all the important MCQs from this chapter? An object of finite height is placed in front of a concave mirror. Within its focus, it forms a real enlarged image. So what is the mirror? Here it is a concave mirror. Okay, so concave mirror within the focus. So this is the focal length. So if you place an object within the focal length, then we know that it is your class 10th chapter. If you remember, if you have studied this in your class 10th, then you should remember. If you have not studied, then I am here to remind you that when the object is less than the focal length, it forms a virtual image. Okay, and it forms a virtual image, enlarged virtual image, which is actually behind the mirror, behind the object, on the same side of the object. Okay, and it's a virtual image, and it will be virtual and enlarged image. Okay, it's a virtual and enlarged image. Okay, sorry, my mistake. Virtual image, how can, for a mirror it will not be on the same side. For mirror it will be on the other side. It will be a virtual and enlarged image. Okay, virtual and enlarged image for concave mirror. For convex mirror it will always be a virtual image but diminished. Now identify the statement which is true for a compound microscope from the following. So compound microscope, the chapter name is optical ray optics and optical instruments. So this question is based on optical instrument. You have only few optical instrument in your chapter: compound microscope, briefly telescope, and reflecting telescope. Okay, Casagranian telescope, that is there in your syllabus. So let's see what question they have asked. Its objective is convex lens of greater aperture. Okay, its eyepiece is convex lens of smaller aperture. The image formed by its objective is real and inverted. the eyepiece produces the final image which is virtual and diminished. Okay. Now let's see what all are true. First of all, you should remember that objective lens is smaller aperture. Objective is smaller because we are observing very small objects using a microscope, so objective will be smaller. Okay, eyepiece will have a greater aperture because it is doing the final magnification, so more the aperture, more magnification is possible. The image formed by his objective is real and inverted. Yes, the first image that is formed by the objective lens is what is focused into the object. So if you remember, if you are from a bio student, then you have used combined microscope in your PU1 classes, okay, where you are doing the different pollen and bisections of onion, etc. You have seen that in the compound microscope, right? So that device is called compound microscope, if you remember. And in that microscope there was a small objective lens which is placed, which you used to rotate it for different magnification, 40x, 100x, 20x, etc. was there, and that was your objective lens, and there was an eyepiece which is fixed, right? So eyepiece is fixed, and the first image which is formed by the objective lens, it's inverted, okay, but then again it is re-inverted by the eyepiece lens, so you see it upright. Okay, that is the reason you see upright image. Okay, now let's move on to the next question. A ray of light is incident on glass air interface at an angle greater than the critical angle of the pair. Okay, so a ray of light, glass water interface, glass air interface. So this is glass, this is air, okay, and it incident at an angle greater than the theta c, that is critical angle. Okay, so in case of angle of incidence greater than that of the critical angle, it will suffer a total internal reflection. That is, all the light that is falling on this will be reflected back completely, so it will be a total internal reflection. If the angle is less than critical angle, then it will partially reflect, partially refract. Okay, if the angle is exactly equal to critical angle, then it will graze the surface, but here the angle of incidence is more than critical angle, so total internal reflection will happen. Okay, so the answer will be total internal reflection. Okay, now next question, question number 4. In case of total internal reflection, the light ray must be traveling from rarer medium to denser medium. No, light ray must be traveling from denser medium to rarer medium. That is the first condition of total internal reflection. Light ray must be traveling from denser medium to rarer medium. Yes, correct statement. The angle of incidence must be less than critical angle. No, the angle of refraction is 0 degree when the angle of incidence is equal to critical angle. No, angle of refraction is actually 90 degrees, not 0 degrees. So this is also incorrect statement. Correct statement, we have found it. So just check that other options as well in case they have done something wrong in the question. So just checking it. Now, a ray of light coming from an object which is incident parallel to the principal axis of a convex lens placed in air after refraction dash. So what is the question? A ray of light coming from an object which is incident parallel to the principal axis of a convex lens. So there is a convex lens. In case of doubt, draw the diagram. Okay, objective 15 questions you have to answer. Okay, and you get a lot of time to answer those questions. Okay, you get a lot of time to answer these questions, so you will have extra time to answer. Okay, now so parallel rays are falling on a convex lens. After reflection, they will converge at focus. They will converge at focus. Okay, appears to diverge, emerges without any deviation, appears to diverge from second principal focus, passes through the second principal focus, passes through the second principal focus. So first focus, second focus, these are not exactly there in your syllabus, but you should know that when the parallel ray of light falls on a convex lens. Okay, if it is a concave lens, then it appears to diverge from first principal focus. First principal focus is on that side, second principal focus is on the right hand side. So a ray of light coming to form in the incident principal as a convex lens. So convex lens means it will obviously converge. Okay, so passes through the second principal focus. Now next question. Now we are doing the fill in the blanks question. From this chapter, a microscope is used to produce large image of small objects. Okay, so obviously we can read the question and we can simply see what is the option. So here it will be image. Okay, micro stands for small. Okay, scope means it big, makes it big. Okay, so it makes the bigger image of a smaller object. Okay, optical fibers are based on the principle of what? Optical fibers are based on the principle of total internal reflection. So see here the option is given, total internal reflection. You can answer this without even thinking. Okay, you don't need to check the options. First write the correct answer, then you can check whether the option is there or not. Okay, reciprocal of focal length is, now reciprocal of focal length means this is called reciprocal of focal length. Right, now let's check the options if you are confused. Virtual, obviously not. Convex, not. Real, not. Power. Okay, so reciprocal of focal length is power. Okay, so now you remember P equals to 1 by F, right? Now dash mirrors are used as rear view mirrors of cars. So what type of mirrors are used as rear view mirrors of cars? Okay, so if you are wondering, there are only one mirror is given here. Virtual is not a mirror, convex is a mirror, real is not a mirror, power is also not a mirror, power is in anyway done, so mark it. Convex is the answer. Convex mirrors are used as rear view mirrors. The image formed by a simple microscope is, so image formed by a simple microscope is what? Simple microscope means what? That looking glass that you use, that is maybe there in your curiosity box if you are having any boxes where you do the Sherlock Holmes things, right? So it is a virtual image, virtual and enlarged image, that is you see the detective see hidden fingerprints, right? So that is the device which is used for seeing simple, even when we are kids, our grandfathers used to read newspapers using that glass. Okay, because it makes the things bigger, right? So this is the virtual, it makes a virtual image and enlarged image. Okay, so that is the property of simple microscope. Simple microscope is nothing but the convex lens, simple convex lens. Now name the objective used in part A. This is now 2 marks question. Okay, name the objective used in refracting type of telescope and B, reflecting type of telescope. There are 2 type of telescope, one is reflecting, one is refracting. So in case of refractive type of telescope, that is for say astronomical telescope, what type of lens is used? Refracting type obviously convex lens is used, and reflecting type concave mirror is used. Okay, you should remember that refracting type convex lens is used as objective, and reflecting type telescope concave mirror is used as objective mirror. Okay, so here you have to mention type of lens, and you also have to mention lens. Okay, in this case you have to mention type of mirror and then add mirror. Okay, concave mirror, convex lens, just it. So if you write this, you will get 2 marks. Simple scoring question. Now write the 2 conditions required for total internal reflection. Very easy common question. Light must travel from denser to rarer medium, and the angle of incidence must be greater than the critical angle. Right, so this is the correct answer. I hope you understood that this is easy question. Now move on to a 3-mark question, which is basically a numerical problem. A small candle is placed at a distance of 20 centimeter in front of a concave mirror. okay, of the radius of curvature 30 centimeter. At what distance from the mirror should a screen be placed in order to obtain a sharp image? What is the nature of the image? So first of all, what are all the information given? Information given as that object is placed at a distance of 20 centimeter. Object distance is 20 centimeter. Now remember that it is a concave mirror. Okay, concave mirror. So you can draw the ray diagram for your reference. Okay, ray diagram is not absolutely necessary in this case, but you can draw that. So object is placed at a distance, say 20 centimeter. Now you should remember that object distance is along negative x-axis. So object distances are always negative, right? You have learned the sign convention in previous class. Also in this class also there is a sign convention. According to the sign convention, object distance is always negative. Okay, for mirrors, if the sign is negative for the image, okay, that is image is formed here, then it is a real image. If the sign for image is positive, then it is a virtual image. We don't know. Now concave mirror has a radius of curvature on this side, right? So suppose this is the center of curvature. So if the center of curvature on the left hand side, because it is curved here, okay, so in fact in this case it is 30 centimeter. So center of curvature won't be here, center of curvature will be after the object. So center of curvature will be somewhere here. Okay, this is the center of curvature. So as you can see, center of curvature is, it will be, radius of curvature will be minus. You need to remember the sign convention to solve any lens or mirror based questions. And for convenience, I told you that object distance will always be negative. Object distance is always negative for concave mirror or concave lens. Both concave mirror or concave lens, the focal length or radius of curvature in case of mirrors will be negative. Okay, in case of convex mirror and convex lens, focal length will be positive. Okay, you can calculate focal length from this. Okay, I am not going to calculate focal length from this because we know that 1 by u plus 1 by v for mirrors equals to 2 by r. So I am going to use this equation, or rather let's not confuse, because I like to use like this, 1 by v plus 1 by u, because for lenses it is 1 by v minus 1 by u, for mirror it is 1 by v plus 1 by u. So that's why it is easier to remember. Now for mirrors it is 2 by r, right? So what is 1 by v? We are trying to find v here, okay, and u, as you can see, is minus 20, so it will be 1 by minus 20, so minus sign I have taken outside, and r is minus 30, so it will be minus 2 by 30, so it will be 1 by 15. If you are wondering why, sir, you have not written f 1 by f here, that also is possible. You can write 1 by f here because f is nothing but r by 2. Then you have to do one step extra here, that's it, right? Now we are trying to find 1 by v. So 1 by v is equal to 1 by 20. Now this minus 1 by 20 goes to the other side, become positive. 1 by 15 was negative already in that side, so it will remain minus. Okay, so 20 and 15, what is the LCM? 20 and 15 LCM is 60. Okay, now 60 means 3 and this is 4 15s are 60, so 4. Okay, so 1 by v equals to minus 1 by 60, so v equals to minus 60 centimeter on the same side as the object, on the same side as the object, on the same side as the object. Now if the object is also image and object are on the same side for mirrors, then it must be a real image. So image must be a real image. Okay, this is slightly different for lenses. For mirrors, if object and image are on the same side, then definitely it's a real image. Okay, so let's see the next question. It is a derivation question. Derive the expression for refractive index of the material of prism in terms of angle of minimum deviation and angle of the prism. Very interesting question, important question. Many students often don't know what to write for this question. They either start exactly at the beginning or just write the final formula. So here I am giving you a precise thing what you have to do. First you have to draw the diagrams. These two diagrams are important, okay, and then you have to explain that for for minimum angle of deviation, okay, for delta mean, okay, I must be equals to E, okay. So this angle must be equal to this angle, okay, that from this graph, okay, I must be equals to E, and then you have to write this formula, okay. Delta M is equal to, from the diagram we can write that delta M is equal to 2I minus A, or I is equal to A plus delta M by 2. Then you have to write also for minimum deviation, okay, A is equal to 2R, and the refractive index is given by N21 is equal to sin M by sin R, and then you have to put the values here, okay. So A delta M by 2 and sin A by 2. You have to write, these are the minimum thing along with the description of the diagram and the condition that you have to mention. For delta M, I is equal to E and R1 equals to R2 equals to R, okay, say. Then you can write these two equations, okay. These are the minimum steps that you have to write. More explanation you can do, that is better, but this do not start with here. If you start with here, you will get 0 marks. You have to explain this, okay, then only you will get the full marks. Now let's move on to a numerical question, okay. An equilateral prism is made of glass of unknown refractive index, okay. A parallel beam of light is incident on the face of the prism. The angle of minimum deviation is 40 degrees, okay. So what are all information given? It's an equilateral prism. So equilateral prism means all the angles of the triangle is 60 degrees. So angle of the prism will also be 60 degrees, okay. Equilateral prism means all the sides are same. That means if you take a cross section, you will get a equilateral prism, equilateral triangle. So equilateral triangle means all the angles will be 60 degrees, right. So that is the equilateral meaning of the equilateral prism means, and the angle of prism is 60 degrees, right. A parallel beam of light is incident on the face of the prism. The angle of minimum deviation is 40 degrees. So angle of minimum deviation delta M is given 40 degrees, okay. Find the refractive index of the material of the prism. Find the refractive index of the material of the prism. Now we know that for refractive index N is given by, now in this case we are assuming that the outside is air. So sin A plus delta M by 2, we have seen that formula in our previous derivation. So the either a derivation or a numerical problem is going to come from this formula. So very, very important formula, you have to remember this. So sin A is 60 plus delta is 40 degrees by 2, okay. Then sin 60 by 2, that is, for 60 plus 40 is 100, 100 by 2 is 50, sin 50 degrees divided by sin 30 degrees, okay. If you put the values, okay, exact values, I am not going to do it. If you put the values, you will get 1.53, okay. That is the refractive index for glass, okay, because it is said glass, so it will come out to be 1.53, okay. You can check the values, okay. Now next question is, if the prism is placed in water, now you are taking the same prism and you have placed it in the water, okay, of refractive index 1.33. Find the new angle of minimum deviation of a parallel beam of light, okay. So now you have to find the new angle of deviation when the entire thing is immersed in water. So you had a prism, so minimum deviation was there. Now you put it into water, and now what will be the minimum deviation, okay. You put it in water, what will be the minimum deviation. Now we know that the formula is n21 is equal to sine A plus delta m by 2 divided by sine A by 2. Okay, what is the meaning of n21? It means that n2 divided by n1. n2 is, we have already calculated 1.53 and n1 is given 1.33. Okay, so equals to sine A plus delta m by 2 divided by sine 30 degrees. See, in this problem, this is taken from your blueprint. The values are not good, so you do not expect that the answers will be cancelled, but when it comes in your board exam, the question papers are checked multiple times so that you get a good values without doing too much longer calculations. Sine 30 is half, so half times whatever value you will get. Okay, 1.53. Even though the problem values are not so good in this case, okay, but in your final exam you will get the good answers. Okay, now if you calculate everything, you will get that A plus delta m will be equals to 70 degrees. Okay, if you use your calculator, find this value, you will get but delta m will be equals to 70 minus 60 equals to 10 degrees, approximately slightly more than 10 degrees, but very close to 10 degrees. So we can write this as delta m is equal to 10 degrees. So you can see the answer. Refractive index is 1.53 and the angle minimum deviation is 10 degrees. So you know the process how you can calculate. The first step, you have to calculate the refractive index of the glass using the formula. In the second case, using the same formula on the left hand side, now what you have to do, you have to find the relative refractive index. Relative refractive index means refractive index of the original medium divided by refractive index of the surrounding medium. Okay, that's it. And use the same formula. In the previous case, delta m was known. In this case, you are trying to find delta m. That is the difference. Do not put 40 degrees here by mistake. Okay, so these are the caution that I am going to give you. Okay, be careful while solving such questions. Now let's see this question again. An object is placed at a distance of 0.3 meter from a convex lens. Okay, so first of all, this is a lens question. Okay, second of all, let us write down all the variables. 0.3 meter from a convex lens. So here object distance is minus 0.3 meter. No matter what, mirror or lens, and unless and until it is clearly stated, you can always take object distance to be negative. Initial object distance can always be taken as negative. Okay, there are some questions where object distance can be positive, but that is not part of PU board. I can guarantee that PU board exam, that type of questions will not come. It will come during your competitive exam for JEE exams, for maybe NEET exam, but not for PU board. Okay, so an object is placed at a distance of 0.3 meter from a convex lens of focal length 0.2 meter. So focal length is given. Now for convex lens, focal length is positive. As I said, for convex lens or convex mirror, focal length is positive. So it will be 0.2 meters. Okay. Now find the position and nature of the image formed. So how can we find the nature and the nature? We know that 1 by V minus 1 by U equals to 1 by F for a lens. Now 1 by V minus 1 by minus 0.3, okay, equals to 1 by 0.2. Now this minus minus will cancel, so it will become plus 0.3 equals to 1 by 0.2, or 1 by V equals to 1 by 0.2 minus 0.3. Okay, so just LCM will be 0.6, 3 to the 6 minus again 3 to the 6, so it will be 1 by 0.6, or V equals to 0.6 meters. So what is the sign of the image? It is a sign of the image is real plus, that means it will be on the right hand side of the lens. Now in case of lens, if the image is on the right hand side, then we can say that it will be a real image, right? So here is the object. my image will be on this side. So object will be at a distance 6.6 meter on the opposite side of the lens, okay, on the other side of the lens. You have to mention that 0.6 meter on the other side of the lens, okay. Now they have said that now this part is done, okay. Nature is, it's a real image, definitely it's a real image, okay. Now let's what is the second part of the question? Second part of the question is also find the distance through which the object should be moved to get an image of linear magnification -1. Now let's understand this point. So when the linear magnification is -1, so in case of convex lens, okay, linear magnification -1 means when the object is placed exactly at a distance 2f, okay, then we get a image exactly at a 2f, okay, then the magnification is -1, right. So for convex lens, because it is a convex lens, so you have to mention that when object is placed at 2f, we get magnification as -1, okay. So this is a special case that you have to remember, that when the object is placed at 2f, you get an image at 2f but on the opposite side and it is inverted real image, so the magnification is -1. So magnification is nothing but v by u, okay. So from there you can find the magnification for lens, right. Now what is the you have to find the distance here. F was given 0.2 meters, right. So what is 2f? 2f is 0.2 times 2, that is 0.4 meters, okay. So 0.4 meters is calculated. Now what was the initial object distance? Initially object distance was u is equal to 0.3 meters magnitude wise, because there is a focus here, there is a focus here, okay. We generally consider this focus for convex lens, right. So now 0.4 meters was 2f. So how much we have to move to make it to 2f? We have to move the distance delta u is equal to 0.4 minus 0.3, that is 0.5 sorry 0.1. What I am doing, my head is not working, sorry for that. 0.1 meter. So object needs to be moved by a distance of 0.1 meter. Let's see the answer. 0.6 meter is the image, okay. It is a real image and the object should be moved by a distance of 0.1 meter to get the real image, right. So here we have completed all the important chapters of your second PU midterm chapters, okay. We will be coming up with the passing package as promised tomorrow. Till then, tata, bye bye, and if you think this video is helping you, don't forget to share with your friends. I'll be back tomorrow.